Hello all. In this video we will continue our discussion of data analysis in Excel. Specifically, this tutorial will examine how to conduct a correlation analysis as well as interpret the results. So, as always, take a moment to open up the dataset Television, Physicians, and Life Expectancy. Okay, now that you have it open, let's examine our variables. Specifically, there are 5 we'll be examining in this tutorial. Life expectancy, the number of people per television, the number of people per physicians, female life expectancy, and male life expectancy. Now, when conducting a correlation analysis, you're going to have to make sure that all of the variables you're examining are measured at the interval level of measurement. These all are. So let's begin by looking at the correlation between two variables. Specifically, let's take a look at whether or not life expectancy and the number of people for television are correlated. So to conduct this analysis, as always, go to your Data tab. So here we are at Data. Go over to the Data Analysis menu. When you pull that up, take a look at your options, and you're going to select Correlation. Once you select that, hit OK. And this is a very straightforward interface. So first we have to select our input range. So you want to make sure you select the two variables you're interested in. So we're interested in life expectancy and people per television. So select both and move all the way down. Once they're all selected, that's fine. They're grouped by columns, right? Because our columns are what we're interested in, looking at the relationship between life expectancy and the number of people per television. As always, labels in first row. Everything else you leave the same and hit OK. Notice an error message popped up. Specifically, it says correlation input range contains non-numeric data. As you'll remember from back in our descriptive statistic analysis, it's these pesky asterisks that are going to get in the way. So hit OK, cancel out again, back to the data, and as before, make sure you delete out where it's asterisk so it's just a blank cell. So there's asterisks at Tanzania and Zaire. We'll delete those out. Now that that's done, let's go back to data analysis, correlation. Our input range is still selected from before, so we don't need to reselect. Everything's fine. We hit OK. And in another sheet, what is here, sheet 6, you'll see our output. So I'll toggle back for a second. Here's our data set. Sheet 6, here are our findings. So this is what's known as a correlation matrix. As you can see, we have our two variables on top, life expectancy and people per television, and the same variables over on the left, life expectancy and people per television. So the way to read a correlation matrix is if you go to a cell, for instance, if you see where there's a 1, this is the correlation between life expectancy and life expectancy. Now, it makes sense as this is 1, which is a perfect correlation, right? Because it's analyzing itself. You can see the same for people per television with people per television. What we're interested in are the correlations for the variables life expectancy and people per television. This correlation, or this cell right here. Now, as you'll remember from your readings as well as your video, a correlation coefficient can range from -1 to +1. The closer it is to 1 in either direction, the stronger it is. And the sign, whether negative or positive, tells you the direction of the relationship. So, in this case, we have a correlation of -0.605. That is a negative correlation, right, because of the negative sign, which means that as the number of people per television increase, life expectancy decreases. Right? So this makes sense. So let's take a look back at this. So in other words, the number of people per television means that there are less televisions around. So what does this mean? It means that these two are fairly negatively strongly correlated. However, I can't stress this enough, and your book does the same thing. Correlation does not mean causation, right? So although these are strongly correlated, it doesn't mean that literally as the number of televisions per people, number of people per television increase, in other words, the fewer televisions there are in a country, the lower the life expectancy. Probably there's something else going around, or going on here. Probably what this is just two variables or two measures of nation's wealth, right? And as a nation's wealth increases, life expectancy is expected to increase as well. So it's important to see what the relationship is between two variables, but you can't assume that there's a causality or there's a causal relationship, just that the two are related. Now, let's go back to our data set again. So notice we have multiple measures. We have life expectancy, people per television, people per physician, female life expectancy, male life expectancy. What's nice about a correlation matrix is it allows you to examine multiple correlations at once. So for example, let's say we're interested in seeing how all four of these measures correlate with one another. How people per television correlates to people per physician, how people per TV correlate to female life expectancy, how people per television correlates with male life expectancy, how people per physicians correlate to female life expectancy, how people per physician correlate to male life expectancy, as female life expectancy correlates to male life expectancies. So as you can tell, that's quite a few correlations, and it would take quite a while if we had to run separate correlation analyses for each. But we don't have to. If we go back to data analysis and open up correlation, and we go back to input range, let's select all of this. Let's select people per television, people per physician, female life expectancy, male life expectancy. Scroll down, make sure all the countries are selected all the way down to Zaire. And leave everything as before, columns checked off, labels in first row, and go ahead and hit OK. So you'll see this creates a correlation matrix that examines all four variables and the relationship between all four variables. As you can see, down our diagonal, as it always would be, these are always ones because they're correlating with one another. And you can see we have 6 unique correlations we can look at. Right. So, if we look at how the correlation between people for television, we'll see that the people per television is correlated to people per physician. As one increases, the other one is likely to increase as well. Again, probably not a causal relationship, or I could probably say definitely not a causal relationship, but still a positive, strong relationship. This is, again, probably two measures of a country's wealth, and that's why they're correlated. And you can see people per television correlates fairly negatively strongly with both female and male life expectancy, which isn't surprising considering our last. We wouldn't really expect that to hit males or females any harder. And they are pretty closely related, or pretty similar correlation coefficients, so that tends to play out there. Now, if we go over to our people per physician, when we look at how that's correlated to male life expectancy and female life expectancy, we see a similar strong negative correlation, which makes sense, right? The fewer physicians there are per people, the lower the life expectancy. Makes sense. And last but not least, we see a very strong, very positive correlation between female life expectancy and male life expectancy. Again, this isn't very surprising, as you would expect these to be highly correlated with one another. There's probably not too much of a difference. Though, note, it's not a perfect correlation, which means there's something else that predicts the difference or predicts the correlation between female life expectancy and male life expectancy. In other words, there's other variables that can come into play. So this is a very quick tutorial on how to run correlation coefficients in Excel and how to interpret it. Notice this is much more straightforward than t-tests or even descriptive statistics. All that comes out are these correlation coefficients. There's no other interpretations that need to be done. If you have any questions, please don't hesitate to email me.